If you like The Legend of Zelda, then chances are you are familiar with the BIGGORON'S SWORD Side Quest in Ocarina of Time. This quest leads you from location to location, trading items in a sequence that eventually lands you the BIGGORON'S sword. But what does this have to do with computing the volume of a solid obtained from revolution? Stay tuned to find out. Here we go! Numerous students have trouble learning how to solve for the volume of a solid made from revolution, but why? My belief is because this is where calculus becomes less cookie cutter and more freehand. Yes, there are formulas to solve for these types of volumes, but they are written too abstractly for most people to fully digest, and it's not exactly clear how to apply them even if you get the gist of what they mean theoretically. When you take away the cookie-cutter nature of slapping formulas down on paper for every problem, something beautiful happens. A moment of pause and a deep breath occur at the beginning of every new problem, since each one brings its own little world. Each problem can, and perhaps should be approached ad hoc, which simply means that you can use the details of the problem to solve it, rather than rely on a cookie-cutter formula. But rest assured, this is actually a pretty intuitive process once you realize that solving these problems is really just an itemized collectathon akin to the BIGGORO'N'S SWORD Side Quest. Let's see this as we work through an example. Example. Sketch the region R bounded by the curves y equals 4x and y equals x squared, and compute the volume of the solid obtained by revolving R around the line x equals -3 using cylindrical shells. At first glance, this seems like it would be really hard. If you're anything like me, then this was also the case when you first tried obtaining the BIGGORO'N'S sword. But instead of focusing on the end goal, we can just focus on the sequence of easy micro-problems. This is analogous to how you can't immediately obtain the BIGGORO'N'S sword, but instead must go through the sequence of easy microquests. First, let's sketch our given curves so that we can find the region R. Luckily, we know that y equals 4x is just a line through the origin with slope 4, so we can draw it like so. This completes our first microquest. We have obtained the giant's knife. Also, y equals x squared is a real familiar smile, and so we can draw it like here. That makes 2 completed microquests, giving us the pocket egg. Now, let's be careful to check where the curves intersect. If we set 4x equal to x squared, then we can solve for x to find that x is either 0 or 4. And that's all for our third microquest, and we hatched the pocket cuckoo. Next, we shade in our region R like this, and we get Kohiro. At this point, we should draw our rotational axis x equals -3. And now we get the odd mushroom. Oh yeah, instead of washer perpendicular, we want to set up an integral using cylindrical shells. So, parallel, washer perpendicular, shell parallel. In particular, the line x equals -3 is vertical, and so we need to slice up our region R with vertical line segments. Solving this riddle was our 6th microquest, which gives us the odd potion. And this means that we will have to go from left to right. That is, we will need to set up an integral over the x-axis. Now we have the poacher's saw. Hey! We know exactly where to start and stop our integral. X is going to go on a journey from 0 over right to 4, since this is where our region R begins and ends over the x-axis. This gives us the broken Goron's sword. Next, we will need a formula for the area of a cylindrical shell using the variable x, but I don't remember how to make this formula. However, I know that it involves a circle, and we know that once we have the circumference of that circle, then multiplying it by the height of the cylinder will yield the desired area. With this riddle solved, we get the prescription. Well, given a point x, we see that the radius of our circle is 3 plus x. The 3 is the distance that we first must travel from the line x equals minus 3 over right to the y-axis, and the x is then that little distance from the y-axis to our choice of x. And so, the circumference is 2 pi times 3 plus x. That was easy! Notice how the line x equals negative 3 played an important role in finding our radius. We use the specifics of this problem to solve for the radius. That's called ad hoc. We've now completed our 10th Microquest, giving us the eyeball frog. Next, we need to find the height of our cylinder over our point x. This is also pretty easy. We see that the top of the cylinder is given to us by the line y equals 4x, and the bottom is given by the curve y equals x squared. And so the height of our cylinder is equal to the top minus the bottom. That is 4x minus x squared. And that's it. We've completed setting up our integral. We now have the world's finest eye drops. Foiling the inside yields 2 pi times the integral from 0 to 4 of minus x cubed plus x squared plus 12x dx. Using the fundamental theorem of calculus, this equals 2 pi times minus 1/4 x to the 4 plus 1/3 x cubed plus 6x squared, evaluated from 0 to 4. This gives us our claim check. We are only one step away from getting the BIGGORON'S sword. We compute our result any way which we prefer and get 320 pi over 3. And that's it. We finally have the BIGGORON'S sword. And so, the seemingly hard task of solving for the volume of the solid obtained by revolving our region R around the axis x equals negative 3 was actually pretty straightforward, and dare I say, easy? All we had to do was shift our focus from finding the actual volume onto just doing the next right thing. Following the BIGGORON'S sword side quest proved useful, and another problem's in the bag. And that's it for today. Math, just like anything else in life, gets easier the more you see it. Take, for example, your favorite movie. I bet you could watch it for the 320th time and still find some new Easter egg in it. So, now that you've seen this video n times, see if you can fill in any gaps by watching it n+1 times. And if you have any questions, be sure to leave a comment down below. If you found this video helpful or interesting, be sure to give it a like, as it helps support this channel. New videos are posted every Tuesday at 2. To never miss out, be sure to subscribe and hit the notification bell. Thank you so much for checking out this week's video. See you Tuesday!